Hello my dear students, good afternoon. Today we will discuss about the shapes of atomic orbitals. So previously we discussed about electronic configurations and then I was given one extra video for electronic configurations of ions and their stabilities we discussed, and today we will discuss about the shapes of atomic orbitals. Atomic orbital means orbitals actually, orbitals. So actually you have a difference between subshells and degenerating orbitals. Subshells means s, p, d, f are called subshells. So in subshells there are degenerating orbitals. No, s has 1 degenerating orbitals, p has 3, d has 5, f has 7 degenerating orbitals. So those are called odd number I was given. So those degenerating orbitals are called atomic orbitals. So orbital means what exactly means? The space in which, the space around the nucleus in which the probability of finding electron is maximum, about 95%, is called orbital. Orbital means which gives maximum probability of finding electron, that is called orbital actually. So the space around the nucleus, definition means the space around the nucleus in which we have maximum probability of finding electron is called orbital. So around the nucleus electron is revolving like this, this, they're creating a wave, and this space is called orbital, and this crest and trough actually called orbital actually. Okay, so electron is revolving around the nucleus in 3 orientations. We discussed in previous also 3 orientations. One is x-axis, one is y-axis, and one is z-axis, like that. So this is atom, spherical manner electrons are revolving. Maybe electron revolving on the axis or between the 2 axes. That is called plane. This is called plane now. And this is what axis actually. So electron revolving, this is the nucleus, electron revolving around the nucleus, understanding, in circular paths actually by creating a wave. Okay, so in that particular wave which gives the maximum probability, means this crust and trough gives a maximum probability of finding electron. This height will give probability of finding electron. This depth will give probability of finding electron actually. So hope you understood. So electron has 2 probabilities. One is on axis, one is between 2 axes, which is called plane. Understood? So this is about the orbital means. What is orbital? I repeat, the space around the nucleus in which the probability of finding electron is maximum, which is about 95%, is called orbital. Understanding? So S has how many orbitals and P has how many orbitals and D has how many orbitals? They all gives what? Probability of finding electrons. So P has 3 orbitals, means P has 3 probability of finding electron, P subshell. One is on x-axis, one is on y-axis, one is on z-axis, like that. Okay, so this is about orbital. Orbital opposite word is called node. In that name only you have orbital gives maximum probability of finding electron, but node gives 0 probability. The space around the nucleus in which the probability of finding electron is probability of finding electron is 0. There is no probability. Where no probability? Suppose at this particular point no probability. Understanding? So here this space gives a probability of finding electron, but at this point there is no probability of finding electron. Please remember all these things. So what is node? The space or point or plane at which the probability of finding electron is 0. Okay, so here we have to discuss about different types of node. One is about nodal plane. Nodal plane means, in that name only you have answer, the plane in which the probability of finding electron is 0. The plane in which the probability of finding electron is 0. That is called nodal plane. Understanding? So there are three planes actually, three-dimensional. We are assuming electron electron probability in three-dimensional. Suppose electron is in xy plane. Understanding? Electron is in xy plane. Therefore, what you can say? Therefore, the yz plane and xz planes are what you can say? Nodal plane, because we are saying electron is present in xy plane, so that in yz and xz there is no electron. So electron present in xy plane, so that yz and xz planes are nodal planes. What is nodal plane? Understood? So I repeat, nodal plane means, you also write down, nodal plane means the plane in which the probability of finding electron is 0 is called nodal plane. If you want, I will write definition. Marina? Nodal plane means the plane in which the probability of finding electron is 0. So I will write definition very clearly. The plane in which probability of finding electron is 0. Right? So this nodal plane this is the example actually what I was given. So if electron present in xy plane, then yz and xz planes are nodal planes for that particular electron. Electron is present means that is its orbital. Understood? So nodal plane means what? It's also called angular node. What is this? Angular node. Another name. Nodal plane or angular node we call. Understanding what is orbital means, what is my orbital right now? Where is my probability? At my home. So where is Giri sir? Means at home. Exactly at where? Is a taking class. So that is my orbital now. This place is my orbital. So in which maximum probability I have. So remaining space of my house is a nodal plane for me. Understanding? Because I am exactly present in front of board. That's it. That is my orbital. Understanding? So this is about a nodal plane, and this is also called angular node. And one more thing, number of nodal planes for any particular orbital is equal to L. Number of nodal planes formula L, small l. Do you know what is L means? L means subshell L is equals to 0, S subshell L is equals to 1, P subshell, that one. Number of nodal planes for any particular orbital. For any particular orbital, the number of nodal planes is equals to L. Do you know what is L? L is azimuthal quantum number. L takes the values 0, 1, 2, 3, 4 and so on like that. L is equals to 0, S subshell. For S subshell, how many nodal planes? Means 0 nodal planes. For P subshell, how many nodal planes? 1. This is what subshell? P subshell. Understanding? Because for P subshell, the L value is 1. So for P subshell, if they ask how many nodal planes, for P subshell, how many nodal planes, means 1 you have to say. Because number of nodal planes formula L. Got it clearly? For D subshell, for D per orbital, okay, D subshell has 5 D orbitals. Clarity have? D subshell has 5 D orbitals. 5 degenerating orbitals for D subshell. Understanding? So simply I will say every time for D, how many nodal planes? I will say like that. So L value is 2. L value is 2 for D subshell. L value is 3 for F subshell. So how many nodal planes or angular nodes for a particular degenerating orbital you can say. Right? have a screenshot. Electron, how present I was given. So what is orbital given? Node I was given. Node two types. One is nodal plane. Nodal plane, another name is angular node. Got it? Have a screenshot and write down. So now I will tell you about one more, that is nodal point. What is nodal point? What is nodal plane? The plane in which the probability of finding electron is 0. That is nodal plane. Now I will talk about another one, that is nodal point. Very important is nodal point. Next, nodal point. Nodal point means, first I will give definition. The point in which probability of finding electron is 0. That is called nodal point. So nodal point has another name, that is nodal region, or else radial node, or else we call that as a spherical node actually. So these are three names what you have for nodal point. So nodal planes we discussed, now nodal points. So nodal points, another name, nodal region, radial node or spherical node. So how to understand this nodal point? This is a spherical path for revolving electron around the nucleus. This height gives the probability of finding electron, and this depth will give probability of finding electron, but these particular points in which the probability of finding electron is 0, this is called nodal point actually. For particular subshell, there are orbitals. There are called subshells. For subshells, how many nodal points are present? Total number of nodal points for any particular subshell. So total number of nodal planes, how many means n minus l minus 1. The number of nodal points for any particular subshell, there is a formula n minus l minus 1. Understood? Suppose for 2p or for 3p or something like that, for 3p, number of nodal points, how many nodal points, or else three names I was given now. These three names you please remember everyone. For 3p, how many nodal points? What is the formula? N minus L minus 1. So for 3p, what is the n value? 3. This 3 will give n value I told or not? For p subshell, S means L is equals to 0. For p, L is equals to 1. For D, L is equals to 2. Do you know this? For F, L is equals to 3. So P subshell, so 3 minus 1, minus 1. Because N minus L minus 1. So 3 minus 1 minus 1. So there is just one nodal point for 3P. Understanding? So nodal point means formula N minus L minus 1. Understood, sir? Any doubt? So if you have any doubt, please ask me, no problem. So how many nodal points for any particular subshell means, because subshell, every individual subshells has nodal points, but nodal planes are same for any subshell. For 2p, 3p, 4p, 5p, whatever. P means nodal planes, L. Nodal planes, L only. But nodal points, N minus L minus 1. These are very, very important. So this example. Now, you know the nodal point. Now, nodal plane also you know. Therefore, total nodes how many? Total nodes is equals to total nodes for any particular subshell is equal to nodal points plus nodal planes. Nodal points plus nodal planes. So nodal points, what is the formula? N minus L minus 1. Nodal plane, simply L. L cancel, so N minus 1. So total number of nodes, how many? Means simply N minus 1. Remember this one. So I repeat, so have a screenshot please and write down. And I repeat, what is that? Nodal plane means will be same for any S, means 1s, 2s, 3s, whatever. Nodal plane for P, any P, 2p, 3p, 4p, simply azimuthal quantum number. But nodal point is n minus L minus 1. N minus L minus 1 is the formula for nodal point. Okay, next we will discuss about that only. It is shape of S subshell. S orbital simply. S orbital or S subshell, if they given, correct only. You know, for S, what is the L value? 0. What is the M value? 0. Because total M values are from minus L to plus L. Do you remember this? Or else total orientations formula. Total orientations 2L plus 1. So 2 into 0 plus 1. 1 orientation. Don't take M value 1. Total orientation 1. What is the M value is 0. Understanding? 1 orientation, that is M value 0. Clarity? So how many degenerating orbitals for S? Only one degenerating orbital. And therefore S has a shape that is spherical. Spherical shape for S subshell, which is therefore you can say spherical means like this. So it has a probability in x-axis, y-axis as well as z-axis like that. Spherical. That's why S subshell is non-directional. Who is non-directional? S is non-directional because it has probability in all axes, x-axis, y-axis, z-axis. In xy plane, yz plane, and everywhere it has a probability of finding electron. So it has probability of finding electron on 3 axes as well as on 3 planes. Understanding? So S subshell is a spherical and it has probability in all the 3 directions. You must write all these things. This is about the S subshell. So for any S subshell, for any S orbital or S subshell, how many nodal planes? Nodal planes how many? Simply L. So for S subshell, the nodal planes are 0. Because nodal plane formula L, nodal plane for S subshell or S orbital is 0. What S, sir? Whether 1s or 2s or 3s or whatever S, the nodal plane is 0 for any S. Nodal point, if you want, nodal point means they must give particular subshell along with principal quantum number. If they given how many nodal points for S subshell, question is wrong. Nodal points, they must give like this clearly. 1s, how many nodal points? For 2s, nodal points for 2s, how many? Nodal points for 3s, how many? Like that they must give. Nodal points for 1s, n minus L minus 1, 1, n value is 1, L 0 minus 1, so 0. Because for S, I was given before, L is 0. So for 1s, n value is 1. For S, L value is 0. So 1 minus 0 minus 1, so 0. Nodal points for 2s, this is actually what? Same story, n minus L minus 1. It's 2 minus 0 minus 1, so 1. Why 2 minus 0 taken understood? N value is 2 and L value for S 0, so 2 minus 0 minus 1, 1. So for this same story, 3 minus 0 minus 1, so 2. So these are about what nodal points as well as nodal plane for S subshell. What is the shape of S? Shape of S is spherical, which is non-directional, and S subshell has only one degenerating orbital, that is one dabba. Okay, so S can have maximum how many electrons? 2 electrons. Do you remember? Like that. And next, shape of P subshell. So you know this. For P subshell, the L value is 1. For P subshell, L is 1. Therefore, the M values are -1, 0 and +1, right? L value is 1, M values are -1, 0 and +1. So therefore, how many degenerating orbitals for P? 3. One is Px, one is Py and one is Pz. What is the shape of any P orbital? These are called orbitals. P subshell has 3 orbitals. One is Px, one is Py, one is Pz. How these have a particular shape means these has dumbbell shape. Dumbbell, you know exercise dumbbells. So 2 lobes they are present. One left side, one spherical, right side, one spherical man. So like that here also you have dumbbell shape. This is okay. So dumbbell means don't draw like this. Like this is a dumbbell. No, this is called dumbbell here in chemistry for P subshell. And here this is called, this particular space is called one lobe. So dumbbell has how many lobes? 2 lobes. This is one lobe, that is another lobe. What is Px? Px means what now? Px means probability in P degenerating orbital, probability of electron only on what axis, you know? X-axis. Only on X-axis. Py means probability on Y-axis. Pz means probability on Z-axis, like that. Means it's dumbbell shape only on X-axis, like this. So this is Px because probability on what axis? X-axis. So this is Y-axis and this is Z-axis. But Px means the probability only on X-axis. Py means probability only on Y-axis, like this. This is Py. Understood? And again this is X-axis and this is Z-axis. You can consider any axis. This I want to consider as X means your choice, not a problem. This as Y means your choice. But in what axis you consider? Y-axis, like this. So on that Y-axis only lobes should be present. Suppose if I am considering this is Y, then Py means lobe should be on this. Understanding? So this is about Py. And what is Pz? You can say now. What is Pz? Means the probability of finding electron on Y-axis, sorry, Z-axis, like this. So this is X-axis and this is Y-axis and this is Z-axis. This is Pz actually. Okay. So about D subshells I will explain clearly later on. Thank you. And we will about F also later on. So you must know all these things, and based on this you will have some questions. And today also no assignment. I will give you one more video, and afterwards we will enter into periodic classification. Few people already learned something about periodic classification. So what they learn I will send for new students, so you also can learn, don't worry. So from classification you must know the periodic properties, because without periodic properties we cannot understand chemical bonding chapter. So chemical bonding and further any inorganic chemistry or organic chemistry about bonding, polarity, non-polarity, everything you can understand by using periodic properties. So you must know all those things. So please remember all these things, very important, and we will enter into periodic classification maybe in our next class itself. Okay.